In this section, we're going to look at what's referred to as chain rule. And here, what you're going to be dealing with is basically a function inside a function. So that's why here you see the function notation, the g of x, inside this other function notation with the f of x. So you're asked to take the derivative of a function inside a function. Alright, so what you're going to do, f is considered the outside function, g is considered the inside function. So you're going to take the derivative of the outside function first, because that's where your little tick mark here is with the f. And then you're going to multiply that times the derivative of the inside function. So derivative of the outside times the derivative of the inside. And there's going to be times that chain rule isn't something that you would have to apply to a problem, but if you did, you would still get the correct answer. Okay, first example here. You're actually going to start this one off by doing the power rule. So the idea of inside and outside here, so when you've done anything with the power rule up to this point, it's only been just x to a power. But see, like inside your parentheses here, you have a whole other function. So your 4 minus x squared would be considered your inside function, and all of this being to the 5th power is considered your outside function. Alright, so starting your derivative, and your first thought may be, well, you got to do product rule because you've got the 3 times the parentheses, but this is just a constant multiple, so you would not have to bother doing your product rule. So just starting with power rule, remember you take your power, you bring it to the front. Okay, so I've got my 3. That's just my constant multiple. So now applying my power rule, I do 5 times my function to 1 less power. So when you're taking the derivative of that outside function, you don't do anything with this part in here. You just do 5 times your function to 1 less power. Now you apply chain rule, and you take the derivative of the inside. Of course, this would be multiplication. Of course, derivative of 4 is 0, so now using power rule to take the derivative of this part, you would actually have negative 2x. Of course, that would drop down to the first power. So on simplifying this, all you need to do is just multiply together what you can. So 3 times 5 times negative 2 is going to give you negative 30. And then you've got your x times the 4 minus x squared to the 4th power. So that would be as simplified as you could go with this one. So, you know, recognizing that you have a function in here, you know, to apply the chain rule to, you have to multiply by the derivative of the inside. Okay, this one is actually similar to the one we just finished, because you will actually start out with power rule. First of all, you would need to rewrite this. So anytime that you have a radical, you've probably already got accustomed to this at this point, you have to rewrite this in exponential form. So this would be the same thing as negative 3 times 2 minus 9x to the 1/4 power. So see, now at this point, like I said, this is basically the same thing as what I just finished working. So my derivative, so I'll use f prime of x. Okay, so this is just a constant multiple, so that'll be negative 3 times. So starting my power rule, I bring my power to the front, so that would be 1/4 times my function to 1 less power. So you've got to do 1/4 minus 1, which is going to give us a negative 3/4. But then you have to multiply times the derivative of the inside. So your inside function is 2 minus 9x. The derivative of this would just end up being negative 9. Okay. You will want to multiply the constant, so negative 3 times 1/4 times negative 9. So that's going to give us a positive 27/4 times the 2 minus 9x to the negative 3/4. And you could have done what I'm fixing to do in the same step if you wanted. I'm just going to take 2 steps here. But you will want to take this and move it to your denominator because of the negative exponent. So that would leave the 27 on the top. And then you would have 4 times 2 minus 9x to the 3/4 power. So you still would need to continue to rewrite things with positive exponents. Okay. Now looking at this one, again, you may first think quotient rule, which is fine. Quotient rule would still get you the correct answer. But as I had told you in the previous section, sometimes you can rewrite your problems, to make the actual process of taking the derivative a little bit easier. What you could do here is actually bring the parentheses to the top, which would change this. Instead of being to a positive 3 for the exponent, you would now have a negative 3. So now this one actually works very similar to the ones we've just finished. Okay, so this is a constant multiple, your negative 5 is. So you start with your power rule. So you would have negative 3 times your function to 1 less power. But then you apply the chain rule and take the derivative of the inside. But the derivative of x would just be 1. And of course the derivative of 3 is 0. So here multiplying times 1, of course that's not going to change anything. So you would have 15. And let's go ahead and do this. Of course, you'd multiply those, but you would want to take this to your denominator to get a positive exponent. So just taking that one little step of rewriting there, you completely avoid having to do the quotient rule, which obviously makes it a whole lot easier.